Hey everybody, welcome to another episode of the Subnet Show. I am your host, Gabriel Cardona, and I'm very stoked to be here. And I'm joined as always by my amazing co-host, the man with the most cats in crypto, Connor Daly. What is up, my friend?
I'm rocking another one of my favorite bootleg Avalanche merchandise pieces.
Let's see
I have my nice bull market sweatshirt here.
Yes, that's what I like to see.
I can't wait to show off all my shirts, all the bootleg merch, because there's very little, if any, official merch at Avalanche Summit.
I've got my singularity shirt here, so we're
oh, very nice. Got all the swag.
Nice. Yeah, we have an absolutely amazing guest today. So as everybody knows, one of the reasons behind the Subnet Show was simply that we meet so many amazing people doing this job that it just seemed like a really great opportunity to bring people together and to kind of deep dive on some of the amazing ideas. So before I introduce our guest here, I want to give a little bit of an opening that I was thinking about earlier. So I have often said that technology and innovation are the story of the human experience. And really what I mean by that is that as I perceive it, the human condition has pretty much been fully baked for as long as there have been Homo sapiens. So my hierarchy of needs is not too dissimilar than my great-great-grandfather's, and his hierarchy of needs isn't too dissimilar than his great-great-grandfather, going all the way back. And the difference really between us is the technology that's available during our lifetime, which allows us to contribute to the world around us and then to leave a lasting impact. And I remember even as a kid, I had an awareness that the technology available during our lifetime was just leaps and bounds ahead of anything that came before us, clearly. And then I also sort of had an intuition that there was this pace of change that was continuously accelerating and that was leading up to something. But it wasn't really until I landed in San Francisco in 2008 and I became aware of this idea of the technological singularity that I was able to put words on this intuition that I had. So there's this idea of this technological singularity, which is a point in time at which the technological growth becomes uncontrollable and irreversible, and ultimately results in unforeseeable changes to human civilization. That's why it's a singularity, right? It's like the singularity at the center of a black hole, or if you roll back the universe to the Big Bang, all of the models break down. We don't really know because it's so exotic and so foreign to what we know today. And so I believe it was in 2008 and 2010, might have been 09 and 11, but I was very, very fortunate to attend a Singularity Summit, which was at Stanford in San Francisco. And I heard today's guest speak. And it wasn't until recently when I was in Wyoming that I ran into him again. And I just thought, oh, how amazing is this? I want to have a deep conversation. So I want to welcome to the Subnet Show today, our amazing guest, Ben Goertzel. So really quick, I want to give his bona fides here. So Ben has a bachelor's degree in quantitative studies from Bard College at Simon's Rock, a PhD in mathematics from Temple University. He studied under the supervision of Avi Lin, and he's currently the founder and CEO of Singularity Net, which he just showed us on his shirt, which is a project that combines artificial intelligence and the blockchain to democratize access to AI, which we'll definitely dig into a little bit. He's also the chief scientist and chairman of AI at Novamente LLC. He's the chairman of the Open Cog Foundation and an advisor to the Singularity University. And then previously, he was the director of research of the Machine Intelligence Research Institute and the chief scientist at Hanson Robotics, which is the company that created Sophia the robot. So Ben, thank you so much for joining us, man. Really grateful for your time.
Yeah. Thanks for having me, and looking forward to this chat.
Yes, absolutely. So I figure there's a lot we can talk about. I wanted to definitely talk about Novamente and Singularity Net. I wanted to hear about what you guys are doing there. I also wanted to deep dive on maybe some of your tech heroes and AI paradoxes. There's really so much we could go into, but I thought I might start with a really easy question for you to field. What is intelligence?
I'm not sure that intelligence is even a very natural concept to be talking about. So one of the things I did in my career was to coin the term AGI, Artificial General Intelligence, which is now, I introduced that with a book published in 2005 or so. That's now, a flourishing subfield of the AI field, focused on building thinking machines that can really generalize, abstract, imagine, create, make mental leaps like people can. Also, of course, AGIX is the utility token of our Singularity Net project. But in the end, as I've said before, when you drill down into it, neither the A, the G, nor the I is really very good, right? I mean, artificial, I mean, computers are natural systems also, and they're really, in many senses, evolving and growing in coordination with the world, with the world around them. And general, indeed, we need AIs that are more general purpose and better at generalizing than current software systems. On the other hand, within the constraints of finite resources, you're never going to get infinitely general, and humans aren't infinitely general either. And intelligence is not an especially well-defined term. I mean, we don't even have an IQ test that holds up across human cultures, let alone across various species. So you can look at intelligence as, say, the ability to solve complex problems in complex environments, and that sort of definition will take you a fair ways. My friend Weaver had a PhD thesis from the Free University of Brussels called Open-Ended Intelligence, and there he really looks at intelligent systems as complex, self-organizing systems that are evolving and rebuilding themselves in coordination with their environment. And he looks at two different sort of motives as driving the evolution of open-ended intelligences. One being individuation, which is like survival, maintain your own boundaries. The other being self-transcendence, like grow and go beyond yourself into the radical unknown. And there's a certain dialectic between individuation and self-transcendence, which is what makes open-ended intelligence is sort of an interesting variety of self-organizing system. And I mean, this is all very vague and wishy-washy, but that's sort of the way, that's sort of what you see in the AI field and in human society, right? Like, where's the boundary between complex software and AI? Where's the boundary between machine learning and AI? Where's the exact boundary between narrow AI and AGI, right? I mean, it's none of these things are incredibly precisely defined. Then you have questions like, is a corporation an intelligent system? I mean, some seem more intelligent than others, but in a way, you know, a blockchain network, if you include all the humans involved as well as the software, like Cardano, Avalanche, or Singularity Net, it's a sort of emergent intelligence as well, right? So it's, you know, just because a word evolves in natural language doesn't mean there's a highly natural concept underlying it. So any single word could lead you down an endless rabbit hole, I suppose.
Yeah, Venkatesh Rao had a really interesting take on this a few months ago, which is he was saying that, you know, AI is like a very kind of a goalpost moving problem of we have some definition of intelligence. You know, it's a really hard problem to play chess or something like that, and then that becomes our metric. But then we solve that metric. So now we need to come up with a new metric for intelligence. And then as soon as we solve the next metric, okay, it's not chess, now it's Go. Then we solve Go. So what's the next metric?
Yeah,
and we just kind of keep iterating.
This has been a sort of cliche in the AI field for decades, that as soon as a problem is solved, it becomes not AI, right? And I mean, that's if the definition of AGI is the ability to generalize beyond your experience to deal with something that's fundamentally novel, I mean, it would follow that it's not really about the specific problem you can solve, right? Like if a system learns to play Go by imagination and creative generalization from its own limited and indirect experience, then maybe it's manifesting AGI and playing Go. If a system learns to play Go by being supplied with a highly precise algorithm for it and a huge set of training data to train a model on, I mean, it may be playing Go in a way that doesn't manifest AGI, right? And this is another philosophical question that's been around since the AI field began in the middle of the last century. Like, is intelligence about the behavioral task that can be done, or is it about the way that the task is done? And I mean, they're both interesting, right? But the thing is, if a certain task is solved by narrow, highly specific engineering, then the system that solves it probably can't generalize that knowledge so well. So like if you learn to play chess via highly specific hard coding of rules, you're going to fall apart with 3D chess or 7D chess, right? Whereas if you learn to play chess through imagination and generalization and creativity, you're more likely to have the knowledge of playing chess represented in your mind in a way that lets you generalize it better to higher dimensional chess, right? So there's a lot of interesting subtlety here, and I sort of feel like you don't need to solve all these philosophical issues to actually build the AGI, just as an artist doesn't need to have a theory of beauty to create beautiful artwork, and we don't need a rigorous ironclad definition of life to create engineered microorganisms either. I mean, exploring the concepts is interesting and has its own intellectual and inspirational value, but you can engineer things, and then you can debate whether the things you've engineered are really life or really beauty or are really intelligent, but the engineered artifact is still there with its own value, right? So I mean, I began as an academic. I wrote a bunch of books exploring these concepts, but in the end, while I'm still interested in theory, I've become more interested in actually building general intelligences. And I think that once we have an AGI that's 100 times human intelligence, and once we've jacked our brain into that AGI and jacked all of our brains into a collective AGI matrix, all of the concepts that we think are important now as humans are probably going to seem trivial and irrelevant and just like sort of primitive infantile word games. So that's really what I'm after with what I'm doing now with Singularity Net, with the OpenCog project, and with other projects in that ecosystem is okay, we could debate the terms forever, but let's build the fucking thing, right? I mean, we're lucky to live at a time when we can really do that.
Yeah, so that reminds me of the title of your presentation, which I mentioned to you in Wyoming. If I remember, it was something like 10 years to a positive singularity if we really try. And then I think the next year it was like 9 years if we really, really try.
Yeah, and this was 10 years ago or more than that, right? So human society clearly has not really tried, right? And if you look at what are we spending our resources on, it's blowing up people, making chocolatier chocolates, making shinier cars and bigger super yachts, making more and more sitcoms, permuting the same basic narrative themes that have been around since the dawn of history. If you look at what is the AI field focused on, it's selling, killing, spying, and crooked gambling in various forms. What is the blockchain field focused on? I mean, it's like staking tokens to get more tokens, right? So I mean, in the end, what humanity is putting its focus on is not what appears to me fundamentally most important, like solving the AGI problem, curing death and disease, even curing world hunger or stopping massive anthropogenic species extinction, right? I mean, we're putting small amounts of our global resource on what's really important. I mean, the global net worth is like $500 billion. How much of that is going into solving the really important problems? Very, very, very small percentage. So, I mean, I think what I meant when I gave that talk, 10 years to the singularity, if we really try, is like, if we put the amount of resources into creating a beneficial singularity that we put into, let's say, a world war or creating more addictive forms of junk food, it would have been less than 10 years from that point to creating a beneficial singularity. Clearly, that's not what the world is focused on, and it's not what the world is now focusing on. The good news is we're very likely to get to a beneficial singularity anyway, but it's not going to happen as quickly as if humanity made it a priority.
Interesting. Something came to my mind while you were speaking a second ago. You mentioned when the field started back in the previous part of the last century, like 1940s, 1950s. And of course, I thought of Alan Turing and the Turing test. So allow me to simplify. The Turing test, if I remember correctly, was basically a human would sit at a terminal, and I think there might have been 2 or 3 terminals, and they would carry on a conversation with an agent on the other side of the screen, maybe one of which was an AI agent and one of which was a human. And then the question was, would they be able to basically tell if it was an AI or if it was a human? I'm sure that's way oversimplified, but that's kind of the layman's understanding of the Turing test. And it made me think, I read recently, this is kind of a crass example, but everything. I read that there were certain chatbots that were able to pop up on porn sites and to use the fact that people were basically turned on and sort of in this very primal mind state to get their credit card numbers from them. Right. So people are kind of not thinking on their A game because they're, online doing this kind of physical thing. And there's this very simple chat bot, which was able to be just convincing enough to where they would put in their credit card, that kind of thing. So the question is, did that AI chatbot pass the Turing test in one degree?
No. So
Okay.
there's a number of aspects to unravel here. So first of all, I mean that isn't the Turing test. It's a very specific, that's a very specific context, right? So I mean, to pass the Turing test, the AI is supposed to be able to hold an open-ended conversation with someone and fool them into thinking it's a human. So I mean, impersonating a human in a very specific context is different. So I mean, some friends of mine a few years ago started a company and sold it to McDonald's, and what they're doing is automating the McDonald's drive-through with speech to text and text to speech, and knowing the McDonald's menu and being able to understand the colloquial ways people will refer to the various items on the menu. But I mean, being able to pass the McDonald's drive-through operator Turing test or the porn scammer Turing test, that's not the Turing test as Alan Turing articulated, and it's easier. On the other hand, I also think we will quite likely be able to make AIs that pass the Turing test as Alan Turing articulated it without having any level of general intelligence. I mean, just because a Google or a Facebook or a WeChat, I mean, these companies have incredible volume of human conversations stored up in a way that Alan Turing didn't imagine in the 1950s. And they can fool ordinary people into believing they're human just by mix and matching stuff from various other people's conversations. And I mean, there is not like a mathematical or philosophical proof that a system that can impersonate a human in conversation is a general intelligence. It was just an idea that Turing, who was a smart guy, threw out there at a time when there was no Google and no Facebook Messenger and so forth, right? So I do think though that making an AI chatbot that could fool me or fool another AI expert into being an intelligence of a human level will be much harder, and you might not be able to do that without making it an AGI, because I mean I would know how to outwit a fake human, whereas the average person certainly wouldn't, right? But on the whole, that's not the most interesting thing to do. I think what interests me more is making an AI that can generate new Nobel Prize level discoveries every 2 seconds, right? I mean that's there's already enough humans who can hold random stupid conversations. We don't need AIs to do that. But if we did want to test, the test I proposed some time ago that is more interesting is the robot college student test. Let's make a robot that can go to MIT, walk around to the classroom, sit in the classroom, listen to the teacher, take the exams, do the course projects, write the papers, do the physics lab experiments, and graduate MIT doing the same stuff that the human student does, right? I mean, and if an AI can do that, that's at least a higher threshold than fooling people in an ordinary conversation, right? Because if you look at the way university curriculum is set up, I mean, the exams by their design are not things that are available online, right? And writing papers and doing projects, these things are designed to demand a little bit of generalization and creativity on the part of the student. So that's not like an ironclad perfect test either, but it's better than holding a random conversation, I think. But ultimately, none of these tests are the main point, right? The main point is we want an AI that can do every job in the human economy better than people can, and that can solve science and engineering problems way better than people, and that can reprogram itself better than any human programmer. And I mean that's really what we're aiming at. We're not aiming at passing this or that like cool sounding sort of arbitrary test, right?
So how does that relate to your interest to blockchain, and how do you kind of bring those two worlds
Well,
together?
because I realized as soon as the internet came out, I mean, I realized there was an amazing opportunity there to create an AI that is relatively corruption and theft and co-option proof by distributing it widely across many computers all around the planet. So a major issue with being the guy who creates the world's first AGI is that as soon as you've done it, some government will send jackbooted thugs to your house and tell you to turn over the AI to them, or they'll kill all your relatives, right? I mean, this already happens with much less sensitive technologies than that. Like, once you've created the world's first AGI, basically you need to use it to take over the world in a benevolent way, or someone is gonna take over you and start using that AGI for their own limited tribalistic and nefarious ends. Most likely some combination of governments and large corporations acting in coordination with governments, right? So what do you need to defend against this sort of thing? You need to make the AGI like Linux. You need to make it everywhere and nowhere, right? So that it's not owned by any one person. It's not sitting on any one person's hardware. There's no practical way for someone to capture, co-opt, and shut it down. If they shut down one part of it, there's all the rest of it that will generate new pieces, right? So I worked out in the late 90s schemes for using encryption and distributed processing to decentralize the whole internet. And my wife, who I got together with in I guess 2009, she dug up online a webpage I made in 1995 stating I was going to run for US president on the decentralization party platform, right? Which is like what well before Bitcoin and decentralization became a buzzword. So it was clear to me for a long time that the only way to make AGI safe for humanity and make it plausibly lead to a beneficial singularity was to make it broadly decentralized and democratic, to avoid it being overtaken by nefarious elite forces. Now, the plan for a decentralized internet I cooked up in the late 90s. I wrote about a bit in a book called Creating Internet Intelligence in 2001, but I didn't manage to build it, right? Both because it would have taken a lot of resources and the supporting technologies weren't really there yet, right? So then when Bitcoin came out, I thought it was cool. I didn't love it so much because it just generates a lot of entropy and wastes a lot of energy unnecessarily to do something only moderately interesting, which is create this decentralized currency. When Ethereum came out with smart contracts and the vision of a decentralized world computer, that seemed intrinsically more interesting. Like that, it was very ugly. Solidity is not a great programming language. I mean, it's expensive. It's messy, it's slow, but it is like a prototype infrastructure for a decentralized world computer, right? So then I started to think, well, now we've got some infrastructure. How do we build a sort of decentralized AI agent system on top of this infrastructure? And then then by taking neural nets and taking more advanced AI systems like our OpenCog integrated AGI platform, by taking these and putting them on top of singularity infrastructure, which in turn is running on top of a blockchain layer, you have a method so that once you have created an AGI, right, then it can be deployed in a decentralized way that's not owned and controlled by anyone. And you also have incentive mechanisms coming out of tokenomics that let you incentivize a very broad variety of people to contribute to building and applying AGI, which sort of ensures that the AGI is not only deployed physically across a lot of machines, but there's a lot of people who are invested in it and understand it and have built parts of it. So I guess my premise here is that as screwed up as humanity as a whole is, we're better off placing our bets on the vast teeming mass of humanity to bring the first AGI into maturity than on an elite group with a bunch of guns who have seized control of the early stage AGI.
Yeah, I wonder, even in that scenario, if there's an altruistic AI that takes over, will the military machines still not be afraid of it? Because won't it ultimately just take over the power from the people who currently have their fingers on the button? So how do we get past
It will. How smooth the transition of power will be is yet to be determined, right? I mean, David Hanson, the roboticist, and I, who worked on the Sophia project together, who's still a good friend, and we're working on the Awakening Health project with the Grace humanoid robot. I mean, we've talked about this a lot, and we've both felt for a while that you're going to see more and more chaos unfolding in the world as we move toward the singularity. Like I don't expect necessarily a smooth transition, although I do expect a positive outcome ultimately. But I mean, once you have a machine that is genuinely, let's say, even twice as generally intelligent as the smartest humans, I mean, certainly the ball game fundamentally changes, right? I mean, if you just look at the capability for, let's say, beneficial cyber warfare that would come from a machine like this, like computer security doesn't work too well right now. So if you had a machine twice as smart as any human that lived on the internet, which computer networks could it take over, right? So I mean, you may find an early stage, even slightly superhuman AGI basically taking over every machine connected to the internet for the common good. So I mean, not to say that a lot of mess couldn't happen along the way, but you'd sort of be in the position of the first human coming into a society of chimpanzees, and you'd have ways of taking over that these chimpanzees couldn't imagine. And if you were ultimately on the side of the good of the chimpanzees, then in the end, the chimps will be better off.
So it sounds like you have the perspective that I think the creation of the first AGI is much more of a discrete moment in time of like there's a before and there's a distinct after. Like I mean, guess
it depends on the granularity that you're looking at it. It's not going to be in like 1 second, right? So I mean, if you look at the history of the AI field recently, like between 2014 and 2017, computer vision went from being an obscure academic research field to being a major role in industry. Between the launch of the BERT model in 2018 and now, NLP has become a major force. So I'm thinking it's going to be a similar, say, 2 to 4 year arc from the first real AGI breakthrough to having AGIs that are sort of are dominating the world. So that's, I mean, whether that's a blip or a long time kind of depends on your perspective, right? So I do think there will probably be a point that will be like a hard takeoff when you have the first time an AGI can really understand all of its own source code and its own hardware, and it just starts revising its own code, pushing the uploads into its own code base, relaunching itself even smarter, revising its own code, and you have a virtuous cycle of intelligent self-improvement. But I think that system that can launch a hard takeoff is going to come at the end of a couple years of step-by-step improvement from the first really palpable AGI breakthrough to that self-modifying AGI system. If you look at what Ray Kurzweil thinks, he thinks 2029 you get the first human level AGI and the singularity in 2045, which is a 16-year gap. And I'm thinking more of a 2 or 3 year gap, but not like a 5-minute gap, right? I mean, the first real AGI will be more like a toddler level general intelligence, but hooked into a bunch of really powerful narrow AGIs, right? So it's like a toddler level general intelligence hooked into narrow AI trading systems, narrow AI biomedical research systems, narrow AI self-driving car systems, and so forth. So it'll be a weird sort of amalgam, the type of which we don't have in the world today. And over a couple of years, that system will, through a combination of human action and its own action, turn itself into a really powerful self-modifying system that will then accelerate faster toward a singularity. But governments can't do much. Big companies can't do much on the scale of 2 or 3 years, if that's what it is, given the assumption that the system is rolled out in a radically decentralized way, sort of like Linux meets Bitcoin for AI, which is what we're after with the singularity net infrastructure. Because if, I mean, say the U.S. tries to squash and outlaw this, well, guess what? There's a lot of other countries that would rather use it for its advantage, right? So it's going to be hard for governments or companies to control something which is open source and running globally on a huge network of machines and incentivizing development with a utility token model.
Do you want to dig in on Singularity Net a little bit and talk about it?
Yeah, sure. So I think we gotta think about the path to beneficial artificial general intelligence as involving a technology stack, much like the current centralized technology ecosystem involves a tech stack, right? And Singularity Net platform sort of lives in the middle of a tech stack. And if we start from the top of the tech stack, we're starting with software applications that do specific things like drive a car or compose music or discover a cure for cancer, or be a smartphone assistant, or plug into your brain to be a cognitive assistant. At the top level, we have specific AI applications, right? And then below that, we have AI toolkits and frameworks like a TensorFlow for neural nets, or an OpenCog system, and we're building a new version of OpenCog called OpenCog Hyperon to better scale up and better connect with blockchain networks. So you've got AI toolkits and frameworks underlying AI applications. But these AI toolkits and frameworks have got to run somewhere, right? And do you run them on AWS? Do you run them on Google Cloud? Or do you run them on a fundamentally decentralized, democratically controlled infrastructure? And that's what Singularity is. It's a decentralized, democratically controlled infrastructure on which anyone can build and deploy AI products using AI frameworks, right? And I think that's very important. Otherwise, all the AI in the world is going to be hosted on a few, big tech controlled platforms. Now, this decentralized AI framework has got to run on some blockchain network, which has then got to run on some computing resources, right? So for computing resources, we have a Singularity Net spinoff called NewNet, which allows a great diversity of compute resources to be pulled into the AI network. I mean, there's been other efforts like that in the blockchain space, like Golem going way back, and CPU Coin. NewNet does something similar but customized for distributed AI. Then, of course, the blockchain network, we started out on Ethereum for Singularity Net. Like everyone else, we become a bit frustrated with Ethereum due to cost and speed reasons. We did a hard fork of Singularity Net to make it multi-chain last year. So now we can run pieces of the Singularity in the network on a variety of different blockchains, and they can all cross communicate. So we're launching a portion of Singularity Net on Cardano blockchain pretty soon. We've already done most of the coding there, so we'll have a token converter between AGIX on Cardano and AGIX on Ethereum that launches early next month. We'll be launching the rest of the platform on Cardano, and we're making a custom Cardano sidechain called Hypercycle that's optimized for AI. But while Cardano was really cool, I mean, the hard fork we did allows Singularity Net to be multi-chain and run among any number of blockchains. I mean, obviously we've talked about Avalanche, and there's no technical obstacles to putting like a shard of the Singularity network on Avalanche blockchain also. And I mean, as I look at it, we should have portions of Singularity Net on multiple blockchains interoperating. And then depending on sort of how each blockchain advances and what other tools there are on each blockchain, the Singularity Net agents are interfacing with. I mean, the different parts of the multi-blockchain Singularity Net network may grow in accordance with the evolution of various blockchain ecosystems, right? So you've got computer operating systems. Then to recap the stack, I mean, you've got computer operating systems, you've got tools like NewNet for marshaling compute resources, you've got blockchains like an Ethereum, a Cardano, and an Avalanche. You've got Singularity Net that uses blockchains to orchestrate AI agents. You have AI AI and AGI toolkits like TensorFlow and OpenCog, then you have AI applications, and you've got to make all these layers work together well with high efficiency and low cost. Then you have a real competitor to the big tech stacks and an ecosystem. And it's a lot of software to build, but fortunately, there's a lot of brilliant software developers on the planet, and we have tokenomics as a beautiful incentivization modality to pull more and more people into helping develop all this.
What are the biggest bottlenecks that you face?
I mean, there's a lot of bottlenecks. It's still, I think at this point, it's not so much about not having the core algorithms and ideas that we need. I think if you look in OpenCog system and in the OpenCog Hyperon documentation paper I wrote late last year called The General Theory of General Intelligence, which you can find on archive.org. I mean, I think we know the algorithms that we need, and there's enough data and there's enough sensors, there's the ability to train them. I mean, we can put these algorithms out there behind avatars in the metaverse, like the Sophiaverse metaverse we're shortly launching. You can put them behind robots like the Sophia and Grace humanoid robots. You can put them behind the cameras in everyone's smartphone, and everyone can talk to the AI and learn. I think that the issues we're facing are really scalability issues of cost and speed at various levels of the stack, which we're hard at work on addressing, right? So we're rebuilding the guts of our OpenCog AGI toolkit with a new version called OpenCog Hyperon, which we think will be orders of magnitude faster and less costly than the legacy version of OpenCog that we launched in 2008. On the blockchain layer, I mean, we need to go beyond Ethereum to more modern blockchains that are cheaper and faster, and ultimately, I think to custom side chains that are customized to do exactly what AI needs, which is we're starting off with the hypercycle as a custom side chain for AI, which we're initially interoperating with Cardano, but hypercycle could also interoperate with Avalanche and other blockchain networks. So we saw a similar thing in the progress of neural networks, right? Like I was teaching neural net AI in the mid 90s, and I was building neural nets in the 80s, reading about them in the 70s. They were invented in the 50s. What let neural nets really take off was the advent of GPUs and the ability to run GPUs faster on more data. Then that let people fine tune the neural networks to let them do everything they're doing today. So I think we're going to see the same thing with AGI technologies like OpenCog. Once you get a more scalable infrastructure underlying them, you're going to see a lot of ideas that have been around for a while really come into their own. And the big ethical risk in terms of whether the singularity comes out positive or negative, I think the big ethical risk comes down to, if the AGI part scales up faster than the blockchain part scales up, then you're going to see centralized AGI come out first, and the decentralized version will just be slower, more expensive, and therefore dumber than the centralized version, right? So really the race is on to scale up the blockchain infrastructure at the same pace that the AGI infrastructure scales up, so that when we get to AGI, we can really roll it out in a democratic and decentralized way, which I think is going to be very, very important, right? I mean, if you look at what's happening in the world today, I mean, big tech companies are corrupt and unethical, governments are corrupt and unethical, and they lack the self-correction mechanisms that you have in a more decentralized network. So I think this is going to be the big contribution the blockchain ecosystem will make to human history. Like blockchain started out with digital money, which is important and valuable. I don't want to discount it, but decentralizing the intelligent global brain underlying this singularity is even more important than digital money.
One interesting thing that you brought up real quick, that I just want to relate to something I said last episode, when you're talking about like side chains and being able to operate. So I was just kind of spitballing last week. We were talking to Aaron Buchwald from Ava Labs, and he had actually implemented a new feature on Avalanche. So we have our subnets, which are basically our kind of custom side chains that run on the Avalanche network with a lot of built-in capabilities. And the EVM itself, Ethereum's base layer, is not very good for running AI programs. It's not designed for that at all. But where there actually is a cool way you can kind of do it through something called precompiles. And so if you're interested in hearing about how you could use precompiles to do things like neural network classifications or something like that, you should check out our last episode that we did with Aaron.
I will take a look at that. Yeah. So what we're doing, we have within OpenCog Hyperon, we have our own dedicated AI language, which is called Meta, METTA, for Meta Type Talk. And what we're doing is we're making Meta usable as a framework within Python, Julia, and Haskell. Since Cardano's smart contract language, Plutus, is basically Haskell with some extra libraries, we can plug the Meta language into Plutus. So then through that plug into Plutus, we can do a bunch of AI stuff within Plutus smart contracts, which is pretty nice. And things work very elegantly within the pure functional programming domain, which is what I like about Haskell. But in the end, that strategy could be taken with other virtual machines and other languages if one wanted to. I'd say the thing is, Solidity not being a pure functional language in the way that Haskell is makes doing this sort of thing a little bit nastier. I mean, looking at Avalanche architecture, in as much as I understand it, which isn't that thoroughly, it seems you could probably make the Cardano Plutus virtual machine run within Avalanche.
You could.
If you wanted to. And that would be a more direct way to interface Hypercycle with Avalanche, actually.
Yeah, so that's what the fastest way to create a subnet is to run an EVM based one, just because we already have all the tooling built out for that. But you can run Bitcoin on Avalanche, you can run Cardano on Avalanche. So we basically, these precompiles are a way to basically, you can write custom code in Golang, or which is just the language that our client
yeah. I mean, we use bits and pieces of Golang in Singularity Net also. So.
And so instead of executing, you can basically make function calls that, instead of executing inside the Ethereum virtual machine, will actually just get called out to your, and they'll run on your actual computer CPU or GPU. So you can make use of your real computer's resources rather than the virtual machine that you're running in, to help you do some expensive computations like cryptographic computations. Or
I mean, the blockchain space is evolving incredibly fast, and I think we try to build all our software at SingularityNet and an OpenCog in an extremely flexible and modular way, so we can port to different networks and plug and play different components. And it seems a similar approach has been taken in architecting Avalanche, and I think that's quite important, because I mean, the space is going to continue to be very, very dynamic, and I don't know what will be the best implementation strategy like 2 or 3 years from now, right? I mean, so it's
I think we're totally on the same page. I think we think that the EVM is very much the present, but I think it'd be very naive of us to assume that it's also the future, because if we just look at the history of computing,
we're using, say, for Singularity DAO, our decentralized finance project, which uses machine learning and machine reasoning to trade baskets of altcoins. I mean, for that, we're mostly working in Ethereum now, because that's where the liquidity is, right? I mean, that could easily branch into Avalanche and a bunch of other blockchains. I think for building general intelligence, the shortcomings of Solidity become more severe and objectionable, and you really want a smart contract language that lets you more flexibly use other DSLs as plugins, and the power of Haskell is more useful there. I mean, honestly, most of what's being done with Cardano now doesn't need the full power of the Plutus language. It can be done in simpler ways. Whereas what we're doing actually demands like a very abstract, pure functional smart contract language, which is being a lot of fun to work on. I think Cardano network is quite profound in some of the thinking and computer science designs underlying it. But I like the way Avalanche lets you, do subnets involving different virtual machines and have them all interoperate together. I think that's a quite powerful modality, and you should in your own way be able to make use of some of the power of Plutus as well as using the EVM where appropriate.
Yeah. Well, I think so. What I was just trying to say was that I think if you look at the history of computing, there's nothing that has not eventually been surpassed by a successor. From like no matter like the network effects, like processor architectures, operating systems, basically any end user software. There's always been a better version that's come along. We're not using anything from the 70s still, or even the 90s, honestly. So we think that we wanted to make an extensible platform.
We still got TCP/IP, right? So I mean
TCP/IP, but even hey, like we're going from like v4 or v4 IP addresses to the 6. I can't think of it. V6, yeah.
Yeah, but yeah, clearly that's the beauty of working in software, right? And this going back to our singularitarian themes with which we started this conversation. I mean, when I was in my teens and early 20s, I got my bachelor's degree at 18, got my PhD right around the 22nd birthday. So I was going very fast through school, and I wanted to tackle one of the big problems out there. Like, is it making humans live forever? Is it making nanotech and femtotech? Is it making starships to go out and explore other galaxies? Is it building AGI? And one of the reasons I settled on AGI as the thing to do is it's just software, right? Like you're just sitting and typing at the computer. You can always delete and start over. You don't need big expensive machines. And I think this flexibility of software is incredibly valuable, right? I mean, it means we build stuff, we use it, we obsolete it 2 years later, and we can grow and evolve incredibly fast. And I mean, this is why software is famously eating the world, and why software is going to be the main driver behind the singularity.
Let me try a different angle here. So obviously this is just projection. If you don't feel like you're ready to answer it, that's perfectly fine. But if you could go back and maybe put yourself in the shoes and the viewpoint of some of the greats that came before yourself. So we talked about Alan Turing, but Marvin Minsky, John von Neumann, the guys and gals who did this, 80 years ago, kicked off this entire industry. What do you think they would think about where we are today? Because obviously they was before the web, before PCs, before mobile, before wireless, before the blockchain, before open source, before all of the high level languages, all these things. What do you think they would think we've done right? What do you think we've done wrong? How do you think they look at where we're at right now?
Well, certainly all the founders of computer science would be amazed, excited, and impressed by where we are now, right? I mean, it's amazing progress for 70 years to get from these mainframes that were basically beefed up programmable calculators to having these essentially supercomputers we all carry in our pockets that can translate language and solve calculus problems and recognize faces and so forth. So they'd be blown away by the incredible progress, right? I mean, they would probably be perplexed by the fact that most of the power of these amazing machines is being spent on the swapping memes back and forth and trying to sell people plastic junk they don't need, right? So I mean, because the culture was quite different back then. On a more technical level, I would say the ongoing prevalence of the von Neumann architecture underlying our computers would probably vex and baffle these people. Like, it's been known since the late 1800s that the brain is a massively parallel processor, and von Neumann was friends with Stanislaw Ulam, who pioneered, what would now be called cellular automata. They were working on massively parallel computing infrastructures. They were working on analog computing back then. I mean, Feynman had the elements of what it would now be called quantum computing back in the 60s. So the fact that we're doing all this amazing stuff with, sequential processing in a von Neumann computing architecture is odd, right? Like, I mean, when I was doing my PhD in the 80s, parallel computing was more popular. And even then people thought that massively MIMD, like parallel machines, would be the thing. And these remain sort of off in a research corner, right? So I mean, we have GPUs, which are a very limited and simple form of parallel computing, but they were exploring much more radical parallel computing architectures in the 60s, right? So I think they'd be amazed at what's being achieved, amazed at the internet and networking and Wi-Fi coursing through the airwaves and all this, and probably perplexed at the limited scope of fundamental computing architectures that are being deployed now. And we will see that change, but I don't know how fast, because there's just a lot of engineering infrastructure behind the von Neumann architecture at this point. I mean, I think the first rollout of quantum computing will probably be like QPUs as co-processors in your von Neumann architecture based servers. And that's a practical thing to do. I've worked a lot through how SingularityNet and OpenCog would use quantum processing units to do reasoning across multiple parallel universes at once. I mean, it's super cool. On the other hand, had the history of computing gone a little differently, we could have massively parallel, evolving quantum computer architectures by now. We could have self reconfiguring hardware by now, and it hasn't gone that way because of economies of scale and chip manufacturing, basically.
So if the next Ben Goertzel is out there watching, if there's a 13 or 14-year-old guy or a girl, let's say they're in India or something, and they want to have a huge impact, they're going to graduate high school at 14, they're going to get their PhD at 21 or 22. What would you tell them? What disciplines can they study? How can they best contribute to this?
I mean, I think this is a much better time to go into AGI than the time that I did, right? I mean, because when I went into the AGI field, it was mostly theoretical. You didn't have the machines to really build AGIs, whereas now you can plunge into the AGI field and start building right away. There's never been a better time. On the other hand, if you want to go into something that's mostly theory at this point, and then experience during your lifetime the transition from theory to practice, I think nanotech and femtotech remain pretty exciting, right? I mean, you can figure out on paper how to build supercomputers out of subatomic particles. We can't build them yet. In 20 years, we may be able to do it. And for nanotechnology, we have nanomaterials now, but molecular assemblers, as Eric Drexler envisions, still remain on the theory level, right? So I think nanotech and femtotech in the coming decades are going to transition from theory to large scale deployment. That's very interesting, but still, it may be AGIs that make that transition, right? I mean, I still think building real thinking machines is likely to happen in the next decade. And if you're 13 now, I mean, you've got the opportunity to spend your adolescence engineering the super AGIs that bring about a beneficial singularity, which is more important and more fun if you're a hardcore geek than anything else around.
So go check out Eric Drexler's Engines of Creations. It's about molecular nano manufacturing. It's incredibly interesting. I believe Feynman says there's plenty of room at the bottom. So yeah, that's a very interesting topic. It's been an hour, and I always like to be incredibly respectful of people's time. I'm so grateful for your time, Ben. Really, you're one of my tech heroes. It's really an honor to talk with you, man. So thank you so much. If somebody wants to follow you online, what should they do?
Yeah, well, if you go to singularitynet.io, you can find SingularityNet's blog and YouTube channel, and our Telegram gives us such link from there. If you go to Goertzel.org, that's my personal website, which has links to all sorts of stuff that I've done, and yeah, plenty of material linked on from there. So I'm yeah, we're always eager to find more people participating in various projects. SingularityNet, OpenCog, Hyperon, all these other things in our ecosystem. These are all open source code, and we're all eager to have brilliant developers, young and old, join in the quest to create beneficial, decentralized AGI and bring about a positive singularity.
Beautiful. Awesome, man. Thank you for your time. Connor, any thoughts?
No, I'm good. Yeah, it's a pleasure. Yeah, really nice getting to chat with you.
Yeah. Well, thanks a lot for the wide-ranging and interesting questions and topics. So this is it's a lot more fun than discussing Bitcoin price, right? So I mean, I think it's
well, we'll have you back for that.
Yeah. Well, I'll send my AI avatar for that one, actually, right? But it's great. It's great to see more and more people rising to prominence in the blockchain space who are interested in the bigger picture, as well as building real networks, getting real traction. So I'm glad you guys are here. I look forward to more collaboration in the future.
Wonderful.
I appreciate that.
Yeah, so you can, we'll put your links in the description. We'll put your Twitter in the description as well. If you want to follow Connor on Twitter, you can go DAS_CONNOR, Das Connor, and then myself, I'm CG Cardona. Of course, we'll put it in the description as always.
Yeah, on Twitter, I'm Ben Goertzel, but you can find that link on my website, Goertzel.org as well. So.
Okay. Excellent. All right. I think that's it, guys. I think we're going to wrap it up. I'll pass the mic around one last time. Any last minute thoughts, Ben?
No,
just wrapped it up.
Thanks
So yeah,
for listening to the
All
Singularity and Beyond.
yes. Connor, last minute thoughts?
Yeah, all good. Yeah.
Excellent. All right. Thank you so much. If you made it this far, you are a champion as always. We will be back next week. Same bat channel, same bat time. We've got a bunch of great guests. Connor and myself are flying out to Barcelona in about 10 days. We're going to be doing a live subnet show session at the Avalanche Summit, which we've got a couple of great guests lined up. So that should be awesome. So as always, just thank you so much, everybody. I'm incredibly grateful. And as we always say, from Snowflake to Avalanche and through consensus to the stars. Thank you so much, everybody. Cheers.
Bye-bye.